Hey guys, in this video we're looking at exam revision for GCSE chemistry, focusing specifically on common 6 markers. So the topic we're going to look at is structure, bonding and properties. So we're going to look at the first 6 marker, which is comparing diamond and graphite, looking at AO1 and AO2. Diamond and graphite are both forms of carbon, and the question we can get asked here is explain why diamond is extremely hard and does not conduct electricity, whereas graphite is soft and is a good conductor of electricity. So we look at explaining the structure of diamond first. Each carbon atom is covalently bonded to 4 other carbon atoms in a rigid, giant, covalent tetrahedral lattice. Covalent bonds are extremely strong and require a large amount of energy to break, making diamond incredibly hard. It does not conduct electricity because all outer shell electrons are localized in covalent bonds, and there are no free or delocalized electrons to carry a charge. We then look at the structure of graphite. So each carbon atom is covalently bonded to only 3 other carbon atoms, forming flat hexagonal layers. The layers are held together by weak intermolecular forces, allowing them to slide over each other, making graphite soft and slippery. Each carbon atom has one unbonded outer electron. These electrons become delocalized and are free to move through the structure to conduct electricity. Second question is properties of ionic versus covalent versus metallic structures. Again, AO1 and AO2. So question can look like sodium chloride has a high melting point and conducts electricity when molten. Chlorine gas has a very low melting point and does not conduct electricity. Explain these differences in terms of structure and bonding. So our possible answer, sodium chloride has a giant ionic lattice. It consists of a giant lattice of alternating positive sodium ions, known as Na+, and negative chloride ions, known as Cl-. It's held together by strong electrostatic forces of attraction, acting in all directions, known as ionic bonds. This requires a massive amount of thermal energy to break these strong bonds, resulting in a high melting point. When we conduct electricity only when molten or dissolved, because the ions are free to move and carry a charge. In a solid, ions are fixed. Chlorine gas has small covalent molecules, so they consist of small molecules known as Cl2, held together by strong covalent bonds inside the molecules. However, it has weak intermolecular forces between the molecules. Very little energy is needed to overcome these weak intermolecular forces, given a low melting point. It does not conduct electricity because the molecules have no overall charge and no delocalized electrons.